Hello friends, in these lectures we are basically cover the 10 important questions from each topic. So today our topic is vectors. So from the vectors and depends on the current syllabus of IIT JEE, we select few questions, just the question that have the trends to come. According to that I am selecting 10 questions. This type of questions may come in the exam. So now question number 1 we are going to discuss a unit vector a unit vector a unit vector perpendicular to the vector minus I plus 2j plus 2k. One unit vector is perpendicular to this and making that vector making equal angle with x axis and y axis. Okay, now then find that unit vector. The question is clear. One unit vector is there, that vector is perpendicular to the given vector, and that unit vector making the equal angle with the x and y axis. So now first of all try to understand what the question says. This is our x axis, this is y, and this is z axis. Suppose this is the unit vector. This vector makes angle alpha here, and same angle alpha he makes with the y axis. Okay, and here he makes suppose some angle beta. So what we know that this is cos alpha, direction cosine again cos alpha, and then the direct cosine is cos beta. So here L, it is also L, and we call this is M. So we already get the direction cosine of this vector. So now this vector if I called R, so this unit vector I can write as unit vector R, which is equal to xi plus yj, in this way. So where x you can write as Li, and you can do one thing, take in this way, because we know the direction cosines, so we can write directly in the form of element. So our R vector is direction cosine Li mj nk, where L and M are equal, so we can write this M as L. Okay, na? So this is our vector. So here one criteria is working. So here the properties of direction cosines, we know that sum of the squares of the direction cosine is 1. From here we have 2L square plus M square, this value is 1. We call this is equation 2. Okay, now. So now one more condition is given, that unit vector is perpendicular to the given vector. So our unit vector is Li, Lj and Mk. So if I take dot with this one, minus I plus 2j and plus 2k. So this will be what? L into minus 1 minus L, L into 2 2L, M into K 2M. This is equal to 0. So what we have here, L plus 2m, which is equal to 0. L plus 2m, which is equal to 0. So now we can find the value of L. L is nothing but minus 2m. L is equal to minus 2m. This value, which is 3, we can plug this value in equation 2. 2 times of L square, that means minus 2m whole square. Then we have again m square, which is equal to 1. Okay, now what we have, 2 into 2 4, 4 into 2 8, 8m square plus m square is 1, 9m square is 1. So therefore m is equal to 1 by 3 with plus minus sign. Okay, now so now we have to calculate what a unit vector. That unit vector we have to calculate. So now r is equal to L. L value we have, L is equal to actually minus 2m. L is equal to minus 2m. So here we can write minus 2m. Then again L is equal to minus 2mj, and here we have mk. So if we take minus 2m common, so it will be I plus j, and if you want you can write 2 here and minus k only. So no need to write 2 outside. So now value of m we know. It is plus and minus, but in front is minus, so it will be minus and plus 1 by 3 2i 2j and minus k. So this is our required vector. Okay, now we are move to the next question. Question number 2. This question says that there is a vector A I plus j plus k. Another vector is B, which is equal to 4i 3j and 4k. Third vector C is equal to I plus alpha j plus beta k are linearly dependent vector. These vectors are linearly dependent. So what is the meaning of linearly dependent? First we understand this concept. Again, given that mod of C value is root 3, then find alpha and beta. Okay, now since here the vectors are linearly dependent, so we have the concept that if we have the vector A, B and C, if they are linearly dependent, then we are able to find the scalar x, y and z, so that xa plus yb plus zc is equal to 0, where x, y and z are not all 0. X, y and z are not all 0. X, y and z are not all 0. So this is known as theorem on linearly dependent. So now, since they said that the vectors are linearly dependent, we are able to find the scalar x multiply with a vector plus y multiply with b vector, z multiply with c vector. The result is 0, where where x, y and z are not all 0. These scalars are not all 0. So now here what we do, put the values of ABC and separate them. So x into I plus j plus k, y b vector 4i 3j and 4k. Next is z times of c vector I plus alpha j and beta k is equal to 0. So now we separate the coefficient of I, j and k. So here we get x plus 4i plus z, coefficient is I. Then we have x plus 3y plus alpha times of z, coefficient is z. This is the coefficient of j. For k coefficient we have x plus 4y and z beta. Then the coefficient is k. Now I, j and k, which type of vectors? I, j and k are non-zero, non-coplanar vector. Non-coplanar vectors. So since I, j, k are non-zero, non-coplanar vectors, so by theorem on non-coplanar vectors, by theorem on non-coplanar vectors, their coefficient should be 0. That means x plus 4y plus z is equal to 0, x plus 3y plus alpha z equal to 0, x plus 4y plus z gamma z beta is also 0. So now this is a homogeneous system of equation, and we know that every homogeneous system of equation has one trivial solution. This trivial solution is 0 0 0, but our assumption is this: x, y and z cannot be 0 all at a time. So therefore we have to search for the non-trivial solution. So for non-trivial solution, coefficient determinant should be 0. That means 1 1 1 4 3, this is 4, 1 alpha and beta. So when we simplify this determinant, we are getting the relationship. What are these? Simplify it. So from here we can write 3 beta minus 4 alpha, number 1. Then again we have alpha minus beta. Then again we have 4 minus 3, that is 1. So 3 alpha, from this is 1, here is 4, here is 1. So 3 alpha minus 4, 3 beta minus 4 alpha, and here also you have minus 4 beta. So minus 4 beta, 3 beta, it is minus beta. 4 alpha and this 4 alpha cancel out, and here you have 1. So that means beta is equal to minus 1, plus 1. We get the value of beta 1. How can we find the alpha? In the beginning we have some relationship. Yes, mod of c is root 3. Since you know that mod of root c is root 3, that means 1 plus alpha square plus beta square equal to 3. Beta is already 1, so we have 1 plus alpha square plus beta square, that is 1 is 3. So alpha square is 1. So alpha we have plus and minus 1. So we get the values of alpha, and here we get the value of beta. I think all of you understand this concept. So here we remember, for the linearly dependent vectors, we have to find the scalar. We have some scalar xyz which are not all 0, such that xa plus yb plus zc equal to 0. And again we apply here theorem for the non-zero non-coplanar vectors. It says that if the three vectors are non-zero and non-coplanar and their sum is 0, it is only happen if their coefficient is 0. Their coefficient is 0. So this idea we apply here. Again here the concept is, it is a homogeneous system. So in homogeneous system, one solution always exists 0 0 0, but we assume that here x, y and z cannot be 0 all at a time. So therefore we are searching for the non-trivial solution, and for non-trivial solution we have to find the determinant. Corresponding determinant should be 0, and that will produce the value of beta. So hope all of you understand this concept. Now going for the next question, question number 3. Question number 3. The non-zero vectors a, b, c are related by a, b and c. They are non-zero, and it is related by a vector is equal to 8 times of b vector, c vector minus 7 times of b vector. Now they are asking a vector and c vector, what is the angle between them? We have to find angle between a vector and c vector. What is their angle? How to find? Very basic level questions you can easily solve if you see the relationship a and 8b. The coefficient of b is positive, that means if a is like this, then the direction of b is also in the same direction. At the same time you notice that c is opposite of b, so c is look like this. This is our c vector. So now you notice that b and c having the angle 180 degree. So I hope all of you understand this concept. Now go to the next question. So that the points with position vector, 4 points are there. A having the position vector a, 2b, 3c. B vector minus 2a plus 3b and c vector. Now c vector, c point has the position vector 4a, 7b and 7c. This is the vectors c point. Okay, now what they are asking, so that the 4 points with the position vector this one more point is there, a, b, c. 3 points are there, are collinear. These are collinear, they are on the same line. Okay, now these 3 vectors we have to prove they are collinear, provided a, b and c are non-coplanar. So if 3 vectors a, b and c are non-coplanar, they are not on the same plane, then we have to prove that these three position vectors are actually collinear. They are on the same straight line. Okay, now so now there is one theorem. So first I will explain this theorem, then we will go to solve the equation. First I explain the theorem. So this theorem says that if 3 points are there with their position vector ABC, 3 points are there with their position vector ABC, and they will be collinear if and only if we are able to find the scalar x, y and z not all zero, such that xa plus yb plus zc is equal to 0, where x plus y plus z is equal to 0. So what is the theorem regarding the three collinear points? It says that if you have the three vectors a, b, c, which are the position vector of the points, then this vector will be collinear if and only if we are able to find the scalar x, y, z such that xa plus yb plus zc is 0 and sum of the scalars must be 0. And here these scalars are not 0 all at a time. They are not all 0 at a time. So this is the criteria. So we want to use this result in this problem. That means basically we want to find xyz. So now suppose x is the scalar, another scalar is y, third scalar is z. So if we have three scalar and if this result is 0, then we have to find xyz and we will show that the sum of xyz is 0. Then it is proved the points are collinear. So we separate the a vector. We will find the coefficient of all the a vector, b vector and c vector. So x into 1, x, 2 into minus 2 into y, minus 2y, 4 into z, 4z and a vector. Then for the b vector, minus 2x, 3y, 7z, b vector. For the c vector you have 3x, then y minus y and then 7z, and this is c vector which is equal to 0. So now here notice that a, b, c are which type of vectors? Non-coplanar. So since a vector, b vector and c vector are non-coplanar and their combination is 0, non-coplanar, and their combination is 0 only when it is possible if all the coefficients of these vectors are 0. That means this will imply x minus 2y plus 4z 0, minus 2x plus 3y minus 7z is equal to 0, 3x minus y plus 7z, it is also 0. So now from here we are going to find xyz. The one value of xyz is very simple, that is 0, 0, 0. So we are searching for the non-trivial solution. So first of all we solve equation 1 with 2 and eliminate x. Then we will solve the equation 2 and 3, eliminate x. In this way you can do, no problem. Otherwise if you add them, so you notice that z is eliminated. So you have minus 2x plus 3x, x minus 3y plus y plus 2y is equal to 0. So this type of relationship we have, so where there is no x. Now try to eliminate z from 1 and 2. So it is multiply by 7x minus 14y 28z equal to 0, multiply by 4 8x 12y 28z 0, add them, these two cancel out, 7x minus 8x minus x, or 14y plus 12y, so you have 2y which is equal to 0. Okay, now not minus 2y we have, so here we get the same equation, x plus 2y is equal to 0. Okay, now we have the same. So what we do, we do one thing, replace x in terms of y. So equation 1 will generate x is equal to 2y minus 2y plus 4z is equal to 0. So this will say it is 4y then 4z is equal to 0, then y minus z is equal to 0, or you have y equal to z. We have again x minus 2y we will put in this equation, x minus 2y second equation. So x equal to minus 2y, then minus 2 into minus 2y plus 3y minus 7z is equal to 0, minus 4y plus 3y minus y minus 7z is equal to 0. Okay, now let me check the calculation once again. X equal to minus 2y, I am putting here minus 2y, so it will be 4. Okay, so we have 4y, 4 plus 3 7y 7z, so again we are getting y equal to z. Okay, no problem. So if I replace here x equal to minus 2y in the third equation, what I have 3 times of x equal to minus 2y, then we have minus y, then 7z is equal to 0, minus 4y minus 7y yes, minus 7y plus 7z equal to 0, so again we have y equal to z. Okay, now so y equal to z we have, so if y equal to z then what will happen, x is what, x equal to minus 2y and plus 4z equal to 0, and y equal to z means y, so we put x equal to minus 2y then 4z, z is y equal to 0, so we have x plus 2y equal to 0. So now we can write as x is minus 2y and z is also y. So our solution is x comma y comma z, and this will be x is equal to minus 2y, y is y, z is also y. So if you take y common, it will be minus 2 1 1. So one solution we can take, x is minus 2, y is 1, z is 1. So you notice that sum of this value x plus y plus z is naturally 0. So it proves that the vectors are actually collinear. The vectors are actually collinear vectors. Okay, now so hope all of you understand this concept. Question number 4. Now next is question number 5. Find the vector components. Question is find the vector component, find the vector components of a vector b which is equal to 2i 3j 6k. along and perpendicular to the non-zero vector 2i plus j plus 2k। तो इस वेक्टर के अलोंग में और परपेंडिकुलर में मुझे निकालना है। तो ये वेक्टर को लोग किससे लिख रहा है? ए वेक्टर से। चलो ठीक है, तो ये अपना हो गया ए वेक्टर और ये अपना हो गया बी वेक्टर, ठीक है ना। तो अब करना क्या है, ये बी वेक्टर के एंड से एक परपेंडिकुलर ड्रॉप करते हैं। ये मान लेते हैं थोड़ी देर के लिए ये एंगल थीटा है, ओके ना। नाउ हियर इफ आई कॉल दिस पॉइंट इज ओ, this point is P and this perpendicular is M. So now we are actually going to find out, our target is here, we are going to find out what is AM vector and what is BM vector. These two we have to find out, okay now. So all of you know that OM vector is nothing but mod of OB, that means B vector cos theta, that I am taking just projection. So mod of B cos theta value we know that A dot B is equal to mod A mod B cos theta. So A dot B divided by mod of A into mod of B, that will be the value of cos theta. Mod B cancel out. So what we have, A dot B divided by mod of A. So this is the OM. So but our target is I'm just taking the OM length. So OM vector is equal to length of OM then OM cap. So here OM vector is A dot B divided by mod of A, this one, and OM vector, that means A cap, we are talking about A cap. So this will be A dot B by mod of A and A cap is A vector by mod of A. So actually we have A dot B divided by mod of A square, then this scalar is multiply with the vector A. These things is the OM. Now how can we find BM? So now if I apply here triangle law, so by triangle law we can calculate. So by triangle law we have OM vector then MP vector, which is equal to not MP, it is MB vector, which is equal to OB vector. So now OM vector is what? OM vector we already know. So MB vector is B vector minus OM vector. So B vector is B vector, OM vector is A dot B by A square, then this one, here not dot any. So this is the perpendicular component and this one is the along the vector. So you know the A and B value, so therefore OM vector will be, just do the dot product A dot B, so you are getting 4 plus 3 plus 12 by 9 and then you have A vector. So it is simply 19 by 9 A vector. 19 by 9 A vector value is what? 2i plus j plus 2k. 2i plus j plus 2k. Now MB vector, which is perpendicular to the OM vector, this is b vector minus this one is nothing but 19 by 9 2i j and 2k. So put the value of b vector, which is 2i 3j and 6k vector. Now minus 19 by 9 2i j and 2k. So your ultimate answer will be minus 20i 8j and 16k divided by 9. So when we are going to find out the vector component of any vector along the another vector or perpendicular to the another vector, so the simple formula is a dot b by mod a square into mod a square multiply with a vector, and b minus a dot b by mod a square in mod a square multiply with a vector. Okay now, so these are the very simple questions, but they may come in the exams. Okay now coming to the next one. Next question they are asking, question number it is based on the Lagrange's identity. Question number 6. A vector cross b vector its whole square plus a vector dot b vector its square equal to 144. A vector is nothing but 4. Can we find mod of b vector is what? So all of you know about this identity. A cross b its square plus a dot b its square is nothing but mod of a whole square and mod of b whole square. So this value given as 144 and it is given as 4 square into mod of b. So now mod b square is nothing but 144 by 16, that is 9. So therefore mod of b is equal to 3. This is very simple questions, but sometime you have to remember this formula. Question number 7, this is little bit interesting. The vector a is a vector minus I plus 2j plus k. This vector is rotated through an right angle. This vector is rotated through a right angle passing through y-axis in its way, and the resulting vector is b. Then the projection of, now we have to find projection of 3a plus root 2b on vector c. So try to understand the question first. One vector is there like this one. This is your a vector, and suppose this is your y-axis. So now this vector is rotated in such a way so that in the new position after rotating 90 degree it will be in the position b. Okay now a vector is given. You have to find out this quantity, projection of this quantity on the vector c. So before finding the b vector we can't do anything. So we have to focus on how to find b vector. So you notice that this three vector is on the same plane. They are on the same plane. If they are on the same plane, so we can say that they are coplanar. They are what? They are coplanar. So by theorem of coplanar vectors we can apply by theorems on coplanar vector. We can say that b is the linear combination of the vector a and the vector y. So y vector, that means y axis is nothing but j vector, so that is j vector. So since it is happened because the vectors are coplanar, so as a linear combinations we can write x times of a vector minus I 2j and k vector plus y times of j vector. So now component wise we decompose and we can write minus xi, then 2 times of x plus y outside j, then x k vector. Like this we have the vector b. Again, here the angle is 90 degree, that means a vector perpendicular to b vector. So by the definition of dot product we can say that a dot b is equal to 0. So if a dot b is equal to 0, so b vector we already know, and a vector is already minus I plus 2 plus k. So take their dot product, so minus 1 into minus 1 plus 1, here 2x plus y, and into 2 plus x into 1, which is equal to 0, because a vector is perpendicular to b vector. So what we have here, this will be x into 1 is x, but let me check, minus 1, and here we have minus x, so it is plus x, so we have 2x plus 4x plus 2y, which is equal to 0. So 2x plus 4x 6x plus 2y, which is equal to 0. Dividing by 2, we have 3x plus y equal to 0. So from here we can find y value. Y is equal to minus 3x. Y is equal to minus 3x. Okay, now a vector A is rotated through a right angle. So since vector A is rotated, we know the property of rotation. If you rotate anything in geometry, their length will not change. So therefore we have one more criteria. A, modulus of A is same as modulus of B. So modulus of A is what? Minus 1, 2 and 2, that means minus 1 square is 1, 2 square is 4, and again 1. So this value is b square, so that means minus x whole square plus 2x plus y whole square and then x square. But x value is y value is minus 3x, we can apply here. So 6 x square, okay, here is x square, so we can write 2x square. Achha, now y value is minus 3x, so 2x minus 3x minus x whole square is again x square, so we have 3x square. So now x square is 2, so what we have, x is equal to plus and minus root 2. What about y? Y is equal to minus 3 times of x, so minus and plus 3 root 2. So ultimately we can find our vector b. B vector we can find. So now b vector is minus xi minus xj and xk. From here we can take minus x common, I plus j and then minus k. Okay, now so now we put the value of x vector, which is plus and minus. Before minus is there, so minus plus root over of 2 I j and k vector. So b vector has two value, so which one is the correct we have to select. Achha, remember in the diagram the angle between a and b is 90 degree, so this is also acute angle, this is also acute angle. So when we take the dot product with j axis, so b dot j, if I choose here positive sign, so what will happen, root 2 I j minus k and j vector. The answer is root over of 2, which is positive. This will imply angle is acute, which is accepted. But if I am taking b vector with j, and here sign is negative, if I am taking I j and k with j vector, So answer is minus root over 2 less than, so which imply angle is obtuse, which is rejected, obtuse angle. So therefore we have to select the positive sign. So out of two vector we have to select the positive signs. So now angle is obtuse, angle is obtuse. So out of two our correct answer is this one. So therefore B vector will be root over of 2I plus j minus k vector. Now they are asking for the projection. So 3a vector plus root over of 2b vector is equal to 3a vector. So now a vector value is minus I plus 2j plus k, and root over of 2 b vector value root 2 I j and k. So actually these two cancel out, we have only 2. So 2I minus 3I, so we have minus I. 6j or plus 2j, it will be 8j. It will be 8j. 3 into k, 3k, or here minus 2k, so we have only k. So minus 3 plus 2 minus 1. 3 into 2 6, 6 plus 2 8, and 3 into 1 3, or minus 2, that is 1 only. Okay, so projection of this vector I called R. So projection of R on C vector, so that means minus I 8j k, take dot with C, 5I 4j 3k, and modulus of the C vector. So modulus of the C vector is why it is happened, 5 square 25, 4 square 16, 3 square is 9, this one. Here the multiplication is minus 5, 32, and then 3. Here we have 50. So 30 we have in the upper part, here 25 root 2, 6 by 5, then 6 root 2 by 5 into 2. So what we have, 3 root 2 by 5. This type of things we have, 3 root 2 by 5. 3 root 2 by 5. I think some answer is wrong. Some calculation mistake is there. It is not 25, it is actually 5. 5. So as a result, this 5 is not present because 25 square root is 5 only. Okay now, so hope all of you understand this question number 7. Now coming to the next one, question number 8 is also interesting, but I want to give you this question as homework. Try to solve it is previous year's questions. Let a vector is equal to 2I plus 3j plus 4k. B vector is equal to I minus 2j and minus 2k vector. C vector minus I plus 4j plus 3k vector. And our A vector is perpendicular to both B vector and C vector. Dot product of A and D is given as 18. Now we have to find A vector cross D vector, square of its modulus, and this result will be 720. You have to prove this result, prove that this will happen. So this is a small task. Question number 9 also I am giving you as a small task. Let alpha is equal to 4I plus 3j plus 5k. Beta is equal to I plus 2j minus 4k. Let beta 1 be parallel. Beta 1 be parallel to alpha and beta 2 be perpendicular to alpha. If beta vector is sum of the beta 1 vector plus beta 2 vector, then the value of 5 beta vector I plus j and plus k is equal to 7. This result you have to prove this. So this is little homework. Now I am going to solve the last question number 10. The unit vector lying on ZOX plane, unit vector is there, one unit vector lying on the plane ZOX, making angle 45 degree and 60 degree respectively with the vector A 2I. Okay, now I write the questions so that you can understand clearly. The unit vector in the plane ZOX making angle 45 degree and 60 degree respectively with A vector 2I 2j minus k and B vector j minus k is, you have to find this answer. One unit vector is there in the plane ZOX. One unit vector is there in the plane ZOX. Okay. So try to analyze this one. This is our x, y and z. So your vector is here. So here present, that means no y component is there. So let our vector is r vector, which is equal to xi plus 0 into j and y into k cap. Is it clear? Because there is no contribution of j cap. Okay, now this vector is what type of vector? Unit vector. That means mod of r is equal to x square plus y square, which is equal to 1. Equation 1. Next is this vector making an angle 45 degree. So cos 45 degree is equal to, with this vector, so 2 into x, 2x, j is not present, and minus y by here 1 into here 2 square 4 plus 4 plus 9 3, and cos 45 degree 1 by root over of 2. So we have 3 times of root over 2, which is 2x minus y, equation 2, making 60 degree with the, so cos 60 degree with this vector. So j is not present here, k y, so minus y, and here b vector is root over of 2 and x square y square is 1. Cos 60 degree is nothing but 1 by half. So now this is root 2. So we are getting y vector is minus 1 by root 2. Y vector is minus 1 by root 2. So our target is only finding the x vector. So 3 by root 2, I am sending y here, which is 2x. So 3 by root 2, y vector is minus 1 by root 2 and then 2x. So 2x equal to 2 by root 2, that means root 2 only. X is equal to root 2 by 2, 1 by root 2. So therefore our required vector are x 1 by root 2I and k is minus 1 by root 2 k cap. Y is this one. So if you want, you can take 1 by root 2 common, I minus k cap. So this is the required vector. So from my side, what type of question may come in the exams in January session 2024 I have done. So all of you please careful about it and try to solve all these questions. In the next session also I am giving you some 10 important questions from some other topic. Till then, bye. Have a nice day.